welcome to a presentation from Radical Ingenuity talking about whether augmented reality is viable for industry today at this moment. So this new way of learning that we have, we've coined the phrase audio-visual instructional demonstration, and it's complicated terminology. What it is YouTube is teaching a generation. You know it. I think people nowadays, a lot of people watch more YouTube than they do TV, because I think people enjoy learning stuff, and it's very simple and very easy to access. So what does that mean for us? Well, our children, our grandchildren, they're YouTube natives and technology natives. So guess what? Future engineers and technicians, this is what they're going to expect. They're being brought up on YouTube learning all this tech, and we present them with manuals with drawings of capacitors. They want outcomes. They don't want to get into that detail like we used to in the past. So what's out there? So this is the ADNOC facility in Abu Dhabi, which is basically a huge data aggregation facility, and it's been around a few years now. But this really still does just show the power of the technology, i.e. aggregation, insight in real time, to be able to operate a facility, mitigate any, estimate any deviations, and then mitigate them in real time, or we're predictive before it even happens. So it's called Industry 4. And we have IIoT. So IIoT is the products associated with the transformation, but Industry 4 is really a shift of the ecosystem. So if it sounds pretty large scale, but it is. I mean, it's a sea change like we've seen in the past, and that's the whole industry's commented on it from the start. So to go back over history, first industrial revolution was based on the introduction of mechanical assistance, steam assistance, machines creating that motive power rather than horses and humans. The second was mass production, so conveyor belt systems and looking at optimizing processes. The third industrial revolution was based on electronics and IT. We've had them a long time. Programmable computers, I've had for my whole career for certain, and long before that. So that none of the SCADA systems, DCS systems, none of that information is new. The fourth industrial revolution is integration and aggregation of all that data, whether it be with the primary architecture collecting what we already have, secondary architecture adding a bit of technology to augment what we already have, and the beauty of all the IT companies been involved is the price of technology has rocketed downwards. So that's a good thing that's going to help us out. There's more to that story. So you have to ask a question: if it's such a big thing, what's your company's strategy? How does it look? Now, for something like this, an electronic scale like this, so IT changes. We've had webmasters because we needed it, because from a marketing point of view, if you like, or communication point of view, we needed these people to be able to communicate in that method. Well, guess what? We're going to have a new skill set. These IoT masters, developers, architects that look at the data landscape and see how we can pull it all together. That will be a career in the future. So why do we need people like me, the grey-haired chaps, engineers for a long time? Why isn't Silicon Valley running away with this? Why aren't 3 years down the line, why isn't everything digitalized or digitized as they've regressed to and automated? Well, it's because we need subject matter experts. The comments are Silicon Valley has AR and VR covered already. We're getting a load of money from a manufacturer to do this. We don't need your help. We don't need an integrator because we've got $10 billion company helping us out. You know, everybody talks about data. You know, data lakes, clean data. Data was the buzzword for the last few years, and then people quickly realised that with all this data, we need to clean it. And then what do we do with it after that? Yeah, the AI and ML, the software guys have worked that out. Yeah, well, you know, there's a reason that we aren't there yet, and the kicker is that they don't have the knowledge of our industries, and they can't fix it if you don't know it. You know, it always needs some sort of guidance, some sort of coaching to get to those results. It's not, this can't be fixed in a silo with IT. Because, you know, AI can only work if it knows its boundaries. It's it's an IT expression, garbage in, garbage out. You know, you can look at an AI boundary and go, yeah, these are the boundaries of everything, but does it help us? You know, no, because we need to have that SME knowledge to be able to know what good looks like and what bad looks like. Um, and you know, a guy sat behind his desk in Palo Alto or whatever, you know, doesn't have that knowledge. He doesn't know what a blocking heat exchanger looks like. He doesn't know what, you know, several factors on a pump set tell him what's actually going wrong. The compounding factor of all of this is, you know, these SMEs are running out, and there's a shift. We all know there's been a shift in the way people look at careers. So if you look at human resources, these are just some data points from McKinsey. Again, like I said, several years old, but still relevant and getting worse by the day. So if we look at, you know, typical working time period, you're looking at 19-20 man hours per person. With these numbers on the right, you're looking at a change of 11% of that number, less people in the manual trades, manual and basic trades. So when it says manual and basic skills for McKinsey, that, you know, we're talking about very educated and knowledgeable technicians in that batch. So what we're going to have of all these numbers is 9 million less people in a job in those fields. So that, yeah, as we said, it's actually mentioned the electricians and craftspeople are in that category. There's a big number, 9 million less people doing that type of work, and you can probably tell already that how difficult it is to get, you know, proper craftspeople anymore. So this example is based on all US sectors. So for the same calculation, the jobs in the high cognitive skills areas, they call it, is going to be 19.6 million jobs. So if we add the 9 million missing people, it leaves a deficit of about 10 million jobs in our industry. So it's going to be at least 11, 12 years to fill the void. That's probably less now, isn't it? It's 9 years or something. So craziness. So let's jump forward and let's see how we fix this. So if we've got less skilled people, but, you know, we have workers, or we have people with hand skills, or you empower them with a basic set of skills to be able to you know, work in industry, we can use augmented reality. And here's an example. So this team, imagine a team where, you know, they had basic hand skills, but they didn't have the insights into what really goes on with an assembly like this. So what can we do? Well, we give them a tablet, we give them a software download and say, well, look, everything that you need to fly this this package is in the tablet. There's no documentation packs. There's no having to look somewhere. There's no linking a document to a panel by going through, you know, folders and folders and looking at indexes. This is all heads-up display, situational awareness, with $100 tablet or less, whatever will fly it. So as you can see, when you hold it up, you get presented with a POI with all that information, and those POIs could include anything that are relevant to that person, a workflow to do some maintenance, some images on what good looks like, what it looked like when it came out the factory, what a data plate looks like, what the schematics look like, and what we can do now is basically pull real-time values from control system as well to be able to pull out values that are actually operational on that system, and we'll show an example of that. But this is from a commissioning, an EPC point of view. Someone in the field, a local content staff, could replicate these actions, directly by watching a video. They don't need any remote training, any 2-week class on how to do this type of work. It's there, it's in front of them, and very, very simple. Any skills can just be distributed globally from one point, rather than having to, travel around the world showing people what to do. So the maintenance legacy, we have lots of data already, lots of information that's been pulled from old architecture, new architecture, all the rest of it. So we have lots of data already. We have the things that went on with the reactive, planned, predictive, and prescriptive maintenance, and this is the evolution that we need to push to. So the reactive world was we fixed it when it was broken. The planned maintenance world was arranged time, schedule works. No matter what state the equipment was in, we were going to maintain it. And it's not like you're building 20,000 Volkswagens or vehicles and you know what the failure mechanism is going to be. Sometimes these are discrete pieces of kit, and at the time when it was made, it was the best guess on what the maintenance should be. So you might be maintaining it 4 times more than you need to. And people reacted to that, and they basically reduced maintenance, and then all of a sudden things started falling over. It's not a blanket fix one way or the other. We did predictive, where we started looking at thermography and vibration analysis. I did that 15 years ago and we paid people to do that, $30,000 a year. They would come and tell us that we had a 5th harmonic increase on our turbine or our centrifuge, and my immediate response to the mechanical specialist would be, what does that mean? Which bearing's going? Well, I don't know. That's up to you to sort out. He wasn't an expert on that piece of equipment, so therefore couldn't help us. All we knew that something was going wrong. So we have to link the machine expertise to the data all in one place, not relying on a single point source of information, but aggregating information to be able to give us that insight from all the experts electronically to do that. So the famous bathtub curve, if we look at situational awareness here, so what we really want to aim for is real-time reliability analysis based on SME, selected analytics. That's a mouthful and a half, but it sort of says the whole thing. So we look at the famous bathtub. We have infant mortality, premature failure. We connected up. Something was a manufacturing defect, falls over. Not much we can do about that. Then we have steady state, normal working life, and then we start to get to the sketchy period in the end where there's a chance of failure. The sweet spot is that we manage that piece of equipment around when it's getting towards its end of life, or during normal operation, is we look at all the analytics and try and maintain that sweet spot, doing what's required to keep it there, rather than it just failing because we missed a maintenance requirement that was actually on its outer limit of its frequency. So we can utilize existing data architecture for this. This is not all new stuff. We don't have to start spending millions on new equipment. A lot of that data exists. There'll be, you guys will know, there'll be VFD drives and equipment with Cat5 connections with nothing plugged in at the moment. So all that data is not being used. So, can we connect up a $100 Cat5 dongle that starts pinging to the cloud or to our local network, whatever we need to do to start pulling that out. You know, it might not be of value taken into a SCADA system for an operator. It might be that, you know, we keep it on the edge and ping it up. It's, you know, all of that's part of the IT infrastructure. So we may need to add some IIoT tech where needed. As was alluded to now, it's really low cost. You know, you can buy Sigfox connected devices that run on their own battery for 2 years for a couple of $100 that, you know, you could connect anything in the world to that that's got a Sigfox network. And Sigfox is a proprietary network for industrial sector, you know, where all of a sudden we're losing 3G now, and how much pain is that going to cost? This is a specific RF band, and for instance, like, you know, it's not like, oh, bleeding edge scariness. It covers the whole of Texas, for instance, and you know, it's got a lot of global coverage. So, and we're talking low price data. So we do have to aggregate that data. We do have to clean that data, and, you know, cleaning that data is probably an SMA activity, if you think about it, or at least putting the boundaries on that. Again, you know, garbage in, garbage out. If these people working on the data don't know what they're looking at, they might get rid of the good stuff. And we've got lots of it, and that's been a big part of the industrial revolution so far, is producing data, because technology was cheap, so we got the data. We need the data. What do we do with it? So then what we do is we create these actionable insights. A prescription, if you like, is, you know, I'm going to the doctors, I'm feeling bad, right? We can fix you. You're not going to fall over. We need to give you some tablets. We need to write a prescription to put the steps in place to get you back on track. And it's the same in the engineering world. Is, you know, we don't have to run things to failure. We can fix them. You know, we do have our annual exam to check that everything's running right. You know, but everybody's different. They have different ways of maintaining their body, and, you know, that's a similar thing. Is, you know, we need to have a specific model for that specific person to make sure they stay on the right track. You know, and then the prescription comes at the end when things start to go wrong, and it's quite a good analogy for a piece of equipment. And yeah, I'm going to say it, you know, prescriptive is much better than preventative, because, you know, we're keeping the costs low, we're keeping the response right, the amount of labour required, everything's on the up, to keeping that machine running in optimal condition. So if we go back to AR a little bit, we look at this one. We have the opportunity for remote situational awareness for all of this as well. So, you know, once we've come up with all of this methodology on how we're going to run our equipment, then putting that data into the field, wherever it may be in the world, is straightforward now. And like I say, I keep repeating it, that the cost of technology is low. So what you're seeing here is, you know, an image, which, this is the beauty of this. This can be all developed off-site. You can take with a photo, and I've proven this myself. We can take that image and hold it up to the real life environment, and it recognizes it. So we have image recognition. Now what you're going to say is that you can't do that because all the equipment looks the same. Well, that's when we start bringing in you know, specific tagging or identification, whatever it might be, RFID, whatever the flavor of what you're working with. So we can see in real time, technician, hands on a tablet, holding it up, can see what's running, what's not, what's over temperature, what needs a service, all the documentation, lockout, tagout procedure completed. If something's not right, you could immediately send off management to change a set point. He could order the parts, or an automation could order the parts that he needs to do the next service level. And basically everything is there in his hand. There's no, you know, going to collect some documentation, opening a laptop, you know, searching through a hard drive or a pile of hard drives in the back of the truck. Everything is there. He's got full situational awareness on a $100 tablet. Now, this all could be HoloLens, as you've seen in the videos. This all could be virtual reality. This could be a guy, stood next to that mud pump in his own office here. Whatever flavour you want to work with, but what we're looking for at the moment is these low cost entries to reduce cost, and this is the way that we do it. So there's all sorts of demos. If you want some more information on this, we can show you, whether it's training, safety, automation, lockout tagout systems. It's all basically pretty straightforward now. But you've got to have the domain expertise to know what you're looking at. If you stand next to an IT guy and you have him 24/7, great. You maybe get somewhere, but we don't all have time for that, and that's why we need to speak to domain experts. So I'm suggesting there's a fast ROI here, because the speed that you can get working on this equipment and get to breakdowns, keep things running, maintain, keep an active eye on maintenance, or even, if that equipment was broken down and someone can see that screen remotely, your SME has just got global power. He can sit in his office in Texas and be there with a guy, in a desert in Kuwait. And guess what? As soon as that one learning point is captured and is managed and is put through its management change, then that goes to every laptop on every facility across the globe immediately. So when that guy in Kuwait gets to the bottom of his problem working with the SME, that immediately that knowledge is empowered to everybody else in the system. And how we're all connected now. We all have supercomputers in our pockets. Just the way it is, and this is why it's an industrial transformation. So if we look at just a basic example of how this could work from an ROI point of view, we have a technician time on a typical job, we have technician time on a connected job. So we compare it. So that, situational awareness. So on a typical job, it might be 2 hours to walk around the plant to get a GSA, whatever. It could be longer. I've spent, when I used to work in the North Sea, getting all the signatures used to take half a shift. Lockout tagout might take, an hour of somebody's time, several people to do that, because it's not automated typically. Gathering documents might take another 2 hours. After you've got your permit, you go back to the workshop and collect your drawings. Then the work that you're going to do is obviously X. And then you might have a handover with the next shift, or your boss to say, right, these are all the things I found, I fixed, went wrong. And this is what you need to put into your, it's a piece of paper. You might want to write this into your CMMS system so the next guy doesn't do it. And it's like, oh, okay, and it goes on a pile. So at least 6 hours. It's pretty conservative. It could be a lot shorter depending on the size of your plant or whatever. Now, if we automate this and we have situational awareness, we're going to say that the permit to work can be done remotely. You can speak face to face if you need to. All of that data, safety data, can be passed over remotely. So lockout tagout could be automated. We've only dropped to 15 minutes, but if it's a digital system that has its integrity levels appropriate to maintain a basis of safety, that could be minutes. But safety, it's going to be a big step to move to that type of system. We don't have to gather any documents, because every single piece of documentation that person needs is in their hand. There's no mid-job, a revision of the drawings wrong, whatever. It's there, it's in the hand. We have the work, handover, 15 minutes, right? There's the file, wrote in real time on the job. All the information's there. If you need anything, give us a call. There's no face-to-face, no showing drawings, red lines, whatever. It's all electronic. So we think that, there's a good 4.5 hours saved on every job. So if you're on a refinery, you can imagine the amount of time that would be saved. And this isn't necessarily getting rid of people's jobs. This is increasing production. It's getting the SMEs on jobs faster, or non-SMEs empowered to fix things faster. So everybody's just working slicker, faster, and people keep the jobs because you've got productive company. This is a training example, so we can, if you've got a training bay in a facility or whatever, or you build one, or even if working off photographs, we can create a training system remotely. It doesn't have to be an instructor that goes out there. The documentation to hand, as we talked about. You've got automated or direct tech. The direct tech, as soon as he's fixed one problem, he doesn't want that call again, so he automates that fix. And you've probably seen now with Teams and Microsoft, with flows and whatever, that Power Apps, that all happens very easily by non-developer type staff. We talked about handover processes, compliance inspections. When you hold up a tablet to a device, it's going to tell you when its last inspection was done, and you might have a red, amber, green, whatever. And imagine that zoomed out to a platform, and we've got this example where a rig manager comes out of his office on a morning and he holds the tablet up to the rig, and it pings all the POIs up and tells him, what's amber, what's red, and immediately he doesn't even have to walk to the plant. He can turn around straight and go to the maintenance manager's office and ask him what's happening with the top drive bearing, because it's showing red and you've missed a PM. And all of that keeps everybody right. It keeps everybody in sync. We're not relying on dusty laptops in offices and all that good stuff. This is all robust industrial engineered PCs and all the rest of it. It's I'm going to say it again, technology is not expensive now. Functional safety proof testing with audit trails. So everything that you do on this, everything that your staff does, or your team does, is timestamped to the second or millisecond if you wish. So that gives you, from a liability point of view and from investigation point of view, there's no cutting corners, there's no process change because the guy, I know this, I'm just going to blitz through it all. You know how long it took for a guy to say that he started the task and finished the task, and it can automatically tell you that he'd finished too early. Again, this isn't developer level stuff, this is integrator level stuff that can program this. So that's hugely powerful for many, many reasons, from investigations, from lessons learned, from spotting the not yet competent guy. We trust people coming onto our plants a lot, don't we? We let them in with just maybe sitting through an induction and let them out on our multi-billion-dollar facility. Well, very, very quickly you're going to get flagged whether this guy is doing the right thing or not, and that helps everybody. That keeps that guy alive, and it makes sure that the plant's maintained and the audit trail's there if anything does go wrong. We mentioned safe system of work. Permit to work systems, all that can be fully automated, including isolations. As I said, the isolation parts, it's only our risk tolerance that's going to stop that. With safety instrumented systems, that are double protected, triple protected by design. If something says it's off, and when it's red on the screen, it's safe to work on or not safe to work on. That can all happen. So that's it. Thanks for staying on. It's 30 minutes, and I appreciate you listening in. Any comments, please feedback. Share this if you think it's going to be valuable within your team. If you want to chat about any of this in detail, please reach out. It's radicalengineering.com. I'm Mark, and hope to speak to you soon. Thank you.